Well, today's session is going to be regarding the limbic system. This is something that I actually found difficult to find information on, and it's not really a topic that's been discussed very well. I try to have a comprehensive overview of the structures of the limbic system and what they kind of involved in. And throughout the session, you'll realize a lot of references to Harry Potter. So, in terms of the function of the limbic system, it is our link between three key things: our emotions, our memory, and our behavior. And they're all very interlinked. Example, it actually is involved in directing our behavior based on past experiences or memories and emotions. So, whenever we do something, it's usually related to something, not even consciously, but subconsciously, even related to something's past in our memory or in our emotions. And we do things based on that. So, for example, if something is good or has good emotions or good memories attached to it, we're more likely to do it in a certain type of way. It is also involved in other behaviors that are needed for survival. So, this is things like feeding, reproduction, caring for our young, and it's involved in our fight or flight responses. So, our sympathetic systems is related to our fight and flight. Similarly, our limbic system is also involved in this system as well. So I want to talk to you about a very important circuit of how this kind of interlink is happening between our memories, our emotions, and our behaviors. So first, we get our environmental information through various senses in our body, from sight, from smell, from taste. And this goes through our parieto-occipital association area. And this is involved with perceptual spatial function. So kind of analyzing the information around us. This can then go into two different areas. It can get relayed to the frontal association cortex, where it's involved with planned behaviors, so planning what we're going to do with this information and our next actions. And also can go into our temporal association area. So in our inferior temporal association area, it's involved with somatic processing. Somatic processing is kind of using our knowledge of the world and really putting meaning into this information. So what does this environmental information actually mean? So putting some meaning to it. These then, after going through the cortexes and the association areas, it then goes into the limbic system. And the limbic system then decides how it's going to act on it. So it can go directly, it can enter the limbic system through two different ways. It can go through the amygdala, which we'll talk about as a component of the limbic system, or the hippocampal formation. And we're also going to talk about that. So there's two parts of the limbic system. From there, it can go through two ways, the outputs. It can go through our basal ganglia, and then this is important for our motor expression of our emotions. Or so after our environmental stimuli, you see something that maybe you don't like, it analyzes that information, it puts our planning and our behavior, and also it puts meaning into that information. Then you might show a face of disgust through that motor expression. A hypothalamus is another output system from the limbic system, and it can then lead to autonomic nervous system. So this can lead to autonomic changes, such as sweating when you're scared, or it can make our heart rate go up. It's also linked with our endocrine system, so it can allow the release of hormones to act on our body and, again, express emotions or behaviors and direct how we should act. So it's really that interplay within all these three kind of important things: behavior, emotions, and memory. Another circuit that's really important, our limbic system, and this really describes how they all link together, is the Pepper circuit. It's a very famous circuit. So it starts off with our hippocampus, and it then, through the hippocampus, it travels up through the fornix. So here's our body of the fornix. And it goes through, so this is the crust of the fornix, and then this is the body of the fornix. And it travels up the fimbria, through the crust, then the body, and then goes through two columns of the fornix. It then reaches our mammillary bodies, which act as our relay station in the limbic system. It relays it up to our anterior nucleus of the thalamus. And the thalamus is a very major relay system in our brain. This can then project into the cingulate gyrus. So the cingulate gyrus is a part of the cortex involved in emotions. Once there's processing of that information, it can travel through white matter tracts down the cingulum. So this is a white matter tract. It carries information from that cingulate cortex all the way down to a parahippocampal gyrus and then back to the hippocampus. And this is just describing the link and how the information travels through our limbic system. So now we'll talk a bit about memory. So 3 types of memories I'm going to talk about. Episodic memory, which is involved with our hippocampal formation. So what is episodic memory? This is memory that we relate back to our past experiences or in our life. So for example, in Harry Potter and in the Deathly Hallows, when Snape is injured by the snake Nagini, he looks into Harry Potter and looks at his eyes and remembers back to how his mother's eyes were. And he tells him that you have your mother's eyes. And this is an example of episodic memory relating back to the past memory. Somatic memory is a kind of our general knowledge of the world. You don't really think about this memory. You kind of look at a calculator and say, that's a calculator. Or you look at a laptop, like I'm looking at one right now, and you say, that's a laptop. It's a general knowledge of the world, and it's involved with our middle and inferior temporal gyri. So in Harry Potter and the Goblet of Fire, looks behind him, the Hungarian horns-tailed dragon, he knows that that's a dragon. And there is no kind of thinking, something that you do subconsciously. Procedural memory is memory that you don't really think about, but it's more with procedures. So for example, driving a car, you don't really think about driving a car, you just kind of push the pedals and turn the steering wheel without really putting too much effort. Or even cutting onions or chicken or something like that. Or riding a bicycle is a classic one. So in this example, Harry Potter is flying on a broomstick, and he doesn't really put any thought into it because it's just an instinct at this point. This is really done by our cortical and subcortical motor systems. Now I'll talk about our hippocampus. And this is something quite famous and well known for our memory, but people really confuse it with this is where our memory is, but it's not. This is not really where our memory is stored. Our memory is actually stored in our association cortices, and we'll talk a bit about that. But what the hippocampus is really involved in is memory processing. It's involved with the formation and consolidation of newly formed memories. So when you experience something or learn something new, and it goes into our long-term memory, this part of the limbic system is very important for that. It's also involved in episodic memory. So as we can relate back to the past, it's involved with using this memory and relating it back to past experiences. And just like it says here, not involved with storage, association cortex. Here you can see a diagram. Here's the hippocampus. You got the fimbria over here, and that's the one that's going to carry all the information up through the fornix and into the mammillary bodies, as we talked about in the Pepez circuit. You got your dentate gyrus over there as well. So this kind of illustrates the relationship of different parts of the limbic system. Now we'll talk about associative areas. So we've talked a little bit in the beginning about your frontal, your temporal, and your parietal occipital. The main role of these areas is it allows adapted behavior to be set and achieved over prolonged time. So it allows us to have behaviors and to control our, behaviors and have some planning in some aspect. So if something happens, we tend not to act with instincts or quickly. We tend to relate back to emotions and past experiences and planning our behaviors before acting on it. And this is what these areas are very important for. So in terms of our frontal neocortex, there's 3 kind of things I'll talk about. Your dorsal lateral over here. So here's your dorsal area, and you got on your lateral side, you got your orbital frontal. So you got your frontal cortex. It's above your orbit of your eyes. And you got your ventral medial, so your ventral aspect, and then the medial aspect of that as well. So let's talk about a dorsal lateral aspect of the frontal cortex. So this is involved in cognitive, executive functions, and also planning a behavior. And it's very important in our risky or moral decision-making situations. So it's kind of our cognitive influence of behavior. So in this sense, in an example in Harry Potter, in the last movie, where he finally realizes that he's a Horcrux and he needs to sacrifice himself in a way to save humanity. This is a very large moral and risky decision that he's made. And therefore, this aspect of the cortex is going to be quite active and involved in this process. Our ventromedial, so we've talked just about our dorsolateral, now we're talking about our ventromedial. This is involved in inhibiting our emotional responses. So it acts to stop us from acting out of emotions. It's very important for kind of day-to-day social and personal decision-making, but it's important that it's different from the dorsolateral because it's not involved in executive and intellectual functions. It's more just for decision making. So remember when in the first movie, Dudley, when he sees Harry Potter's birthday cake, he sees it and he knows it's for Harry Potter, but he goes and just eats it because he's hungry or he's just acting out of emotions. This shows probably an impairment. So if someone's got impairment of ventral medial prefrontal cortex, they don't really think about the immediate consequences. They just act out of emotional responses. And then our last thing is our orbital frontal cortex, which we'll talk about. So this is more about instinctive, motivational, and emotional drive. So it's more about emotion and reward aspect in decision making. We've got a medial and lateral aspect of it. So medial is more for rewards, lateral is more for punishment, and it's more effective influence behavior. So in an example, I can't remember which one this is from, but this is from the Half-Blood Prince, where Harry studies the Half-Blood Prince. It's a book, and he studies it because it tells him secrets of how to make potions really well. And he's getting constant praises from his professor, Professor Slughorn. And this gives him like a reward, and he encourages him to, I guess, keep studying and keep creating potions, where at the end, he actually won a prize, the Liquid of Luck. And so this is, I guess, this part of the cortex is involved in this reward system. And it can be involved in things like gambling. So someone who's got impaired orbital frontal cortex wouldn't really understand the importance or why people gamble. They don't really, I guess, have that emotional reward in decision making. Now we'll talk about amygdala. So this is also quite kind of a famous part of the limbic system. People always think it's due to fear and anxiety and sometimes even anger. And it's true that in a sense it is involved in coordinating fear and anxiety. It is true. However, a very important function of the amygdala is it attaches strong emotional content to memories. And it affects, because it attaches that strong emotional content, it affects how well memories are stored. So memories with stronger emotions tend to stick better. So if you think about it in our life, things that have very strong emotional influences, we tend to recall it much better. And that's what the amygdala is for. And we can see this amygdala very close to the hippocampal formation. And the way that the main output system is the hypothalamus. So when the amygdala is active and wants to display this emotion, it's going to send through the stria terminalis, a fiber system that goes all the way around into the hypothalamus, and then it can, release autonomic. So you start to sweat, your heart rate starts to go up, your blood pressure starts to go up, with more fear and anxiety kind of responses. So this is what the amygdala is for. Now we've got our cingulate gyrus. So remember in our Pepez circuit, when hippocampal formation goes all the way up the fornix, into our mammillary bodies, and then up into our cingulate gyrus. And this is what is important in emotion formation. So it forms emotions and processes them. And then once it's done that, it can project the information back to the hippocampal formation, so to the entorhinal cortex, via the cingulum. So cingulum is just a white matter tract. Yeah. And now we'll talk a little bit about pathologies. So in terms of pathologies, there are three kind of things that we should think about. Whether the pathology is affecting just the limbic system, so selectively involving it. Example, limbic encephalitis, herpes simplex encephalitis. So this is a viral encephalitis that just affects the temporal areas, so selectively involves it. Or whether it's predominantly involving it. So it affects somewhere else as well, but mainly the limbic system. Or if it's just randomly involved, so maybe you've got a disease process and it's just caught it by accident. So a very important example is things like Alzheimer's disease, one of the most common form of dementia. It involves a lot of our hippocampal areas. You've got frontal temporal dementia, randomly involves the things like if you've it's not a part of the disease process to affect the limbic system, but it's accidentally or something has. So this is through neoplasms, vascular inflammatory lesions. So I want to talk about Alzheimer's disease because that's a very common one. It's a chronic neurodegenerative disease. It's a leading cause of dementia in the developed world. And it starts off with the severe atrophy of hippocampal formation. So it starts off with the shrinking of the hippocampus and also can lead to cortical shrinkage as well. But it starts off in the entorhinal cortex and these areas. And as it spreads, as you can see, you can get severe cortical shrinkage. It can also affect parts of the brain that can lead to cognitive decline as well. And when it starts off in the hippocampal area, remember what the hippocampus is important for. It's important for episodic memory and turning short-term memory into long-term memory. And that's what is impaired first. Then later on, you'll see the cognitive decline as well. So that's the end of the limbic system. I hope that was useful. Let me down in the comments what I should cover next. And yeah, remember to like and subscribe, and I'll see you guys next session. All right. Thank you.